The initiative to start the activity was raised by the German National Committee, mainly driven by German utilities.
Is there any chance that IEC 61150 will be replaced by any other standard?
In order to stay up front of the technology, you better contribute to the development of the technology.
How much time do you spend on IEC 61150 in your life?
I better don't want to count that.
Okay, Christoph, thank you for the opportunity to meet with you and to ask you several questions. And I suggest that we start with the first question. IEC 61150 is the first standard which introduced something new in protection and automation area, mainly GOOSE and Sampled Value communications. Was this idea from the very beginning? And who introduced this idea? Was it a protective guy or some team of protection specialists? How it happened?
Well, I wouldn't say that it was from the very beginning when we started with 61850. I mean, the first idea was to standardize what has happened already before with the introduction of communication into substations. So they have a kind of a substation automation system. So the first major idea was really just standardize on the level that we were able. But then, of course, at the same time, there was also the new technologies coming up with sensors. But that required a new kind of a signal, either a low voltage analog signal or something different. And that was where the idea for sampled values was born. On the other side, the replacement of the wires for schemes like protection schemes with a GOOSE messaging, that was an idea that was originally developed at those time UCA2 activities that were going on in the US.
Okay, so these activities were led by a team of protection engineers, so this is basically what is of the interest. Is this idea, is it coming from protection guys or just from automation guys?
I think the GOOSE was mainly coming from protection guys as far as I know. But as I say, that was originally introduced in the UCA activities happening in the US.
Okay, so what's the overall team of the people, what's the number of people that participated in the creation of IEC 61150 original series?
The original series, we started with 3 working groups. We had a working group 10, 11 and 12, where 10 was responsible for the overall system aspects, 11 for what we called station bus at that time, and 12 for process bus. Each of the groups had about 50 people maybe at that time, 30 to 50 people as members.
Mm-hmm. And the year when it all started? I mean,
it started in 95 officially. There was an ad hoc working group before that was in place between 94 and 95, I think, if I remember correctly. That was more or less investigating and was making this suggestion to create 3 working groups to address the topic. And I think in November 2005 we had the first meeting in Switzerland, in Baden.
Okay, but well, in Russia most of the people say that IEC 61150 is something that was enabled and developed by the major manufacturers who wanted to present their interest, to introduce their interests in local markets, for example, such as Russian market. And the question is, whose initiative it really was to start this?
The initiative to start the activity was raised by the German National Committee, mainly driven by German utilities in 1993 where there was a plenary of TC57 in Sydney. That was when it was originally introduced or raised as a proposal. And as I mentioned, based on that, we then created this ad hoc working group that was looking into how to address that. But the initial request was coming from the end users, from the utilities in Germany.
And of course, in these groups, were there any manufacturers, like representative of manufacturers in these working groups which were established?
When we established the working groups, there were mainly manufacturers as members. There were a few utilities that participated, but the whole development was mainly done with manufacturers and consultants in the working groups, which is a little bit natural because for utility people it's very difficult to travel outside their country. So that was probably one of the reasons why we have mostly manufacturers and consultants in the groups.
And how did you get involved in all this that is connected with the IEC 61850?
I was working at that time for Landis & Gyr, a company in Switzerland that did SCADA systems, and they delegated me as an expert at that time for station bus into first in that hoc task force and then in what was the working group 11 at that time.
And then in some time you become a convener.
I later on changed my job, changed to ABB, where I was dealing with process close devices like CTVTs, and that's when I became convener of the working group 12, which was at that time responsible for the process bus. So basically we invented the sampled values. And then later on, once the first edition of IEC 61850 has been more or less finalized in 2004, it was decided to merge the three working groups, 10, 11 and 12, into one working group to maintain the standard and further develop it. And that's when I became the convener of working group 10, because out of the three conveners we had then, 10, 11 and 12, I was the only one more or less to continue. So that's when I became the convener of working group 10.
Well, much time passed since that time, and throughout the time you've been participating in the development of IEC 61850. What do you see the most important steps that happened?
I think there was certainly important decision made, and I think that happened around 2003, 2004 as well, to expand the scope beyond the substation. The original scope of 61850 was really limited within the substation, because IEC had other standards like 6875 series for the communication towards control center. There were other standards for communication between substations, but somewhere around 2003, 2004, the Swiss National Committee basically raised two new work item proposals to go beyond that scope. That's when we extended the scope to be used as well in other, first to be used for communication outside the substation. And in parallel, there were other industries that started to look into standardization of certain elements, and they were also interested in 61850, which was the hydropower people, as well as the models for distributed energy resources. Both activities started in 2004. So when we, on one side, merged the working group 10, 11 and 12 into one working group for maintenance, there were, at the same time, we created these two new working groups, 17 and 18, to deal with these other domains. Another thing that started already before that was the wind power industry that started to adapt the concepts in their 61400 standard. So they used 61850 concepts. They had a little bit some deviation because they were a little bit a step ahead. So the coordination at that time was not yet that perfect. So that's why they have some, first of all, why they have an own standard series, and why some of the concepts are a little bit different.
Okay, and if to look at the forecast for the future, what will be the main game changers there for IEC 61850? What will be the key improvements that are already seen?
I mean, the current activities, there's a huge effort focusing on improving the engineering interoperability. In the initial work that we did on 61850, the focus was on communication. A little bit the semantic models, that was something new that we introduced as well. And I think the really significant new step, introduction that we also did originally was the introduction of the substation configuration language. The only point was at that time we didn't really have yet an experience with that, because it was something completely new to the industry. So over the time we discovered that while the concepts were well defined, the way how it could be used by the different vendors, by the different tools, was still too much variations, so it didn't really facilitate the engineering process to the level we were expecting. So mainly in the last 5 years, 5 to 8 years, I would say, driven by feedback from users like the NSOE, the European Transmission System Operators, we invested a lot of time in improving these aspects, and we are still investing a lot of time to further enhance the features behind the engineering aspects.
And utilities around the world, do they design really using SCL?
There is not yet so many utilities that do the integration themselves. Most time today when we have 61850, it's either a design of a substation by a vendor as a kind of a turnkey, or there is in some cases third-party system integrators. Vendors, it depends a little on the tools they have. Many of them are using the SCL in a full concept for the engineering. Sometimes shortcuts are made, which typically become costly later on. But now the more and more, and again, as an example from NSOE, utilities are getting into the 61850 world that want to make the designs themselves, and are looking for tools available to support that process.
And these utilities, they make such requirements, I mean, to produce SSD files, SCD files. They usually do this.
Yeah, SSD maybe not yet so often, but definitely SCD files. The specification sometimes is still lacking a little bit. But there is an interesting European research project going on currently, the Osmos project, where, again, driven by some utilities, with a couple of vendors, we are investigating in the full path from a specification to the design. What we want to achieve there is to be able to enhance the specification with beyond the pure functional specification, so that we can already define a virtual signal flow at the design stage, so that the utility can, at the specification stage, not the design stage, at the specification stage already specify signal flows, more or less specify the whole design in a device-independent way, which also allows them to use simulation tool to verify the design before it's really going out for tenders. Okay. And that's what we investigate in that project.
So in Russia, the design is mainly done by the independent companies, which are hired by the utilities, and we'd also have a requirement that electronic documentation like SSD or SCD should be developed at the design stage. And the main question from our companies which do the design is, what tools should we use? How do you think, is this market is already ready to provide us with such tools?
There's definitely a few vendor independent tools out that are doing quite a lot. They are pretty advanced. So I think, yes, there is certainly some market there. Probably not yet many different providers, but I also don't expect there will be tens or 20s of providers, because it's still a limited market in general, and it's a lot of investment to design those tools. But there is a few tools available that are definitely usable.
But those teams which develop such tools, do they work with the utilities? I mean, maybe European utilities, American utilities? Is there such experience?
Yes, I mean, some of those tools, I don't want to name names here, we don't do marketing. Some of these tools are really developed based on feedback, working with projects, with customers on projects, adding new features project by project that I have been doing. So expanding more or less the functionality driven by user requirements.
Okay, and the last question about this SCL documentation is, in your opinion, what is the key benefit for the utilities? Which should they understand about using this SCL configuration language? Just what it gives them in the end?
Okay, it depends a little bit on the design process. When they are not making the design themselves, it still gives them an overall documentation of the system. It allows them also later on for the maintenance to have a standard-based approach, a standard-based documentation. They become independent of the device-specific vendors, so they can change later on also the vendors, still integrate them into the design that they have made once, or if they need to make extensions. That's definitely one of the aspects. The other aspects behind the whole SCL process is, and that's also what we partly investigate in this Osmos project that I mentioned, that's really the possibility to be able to do simulation of designs, simulation of even if some equipment is not yet there, you can simulate it. So it allows you, as an example, when you have a maintenance case, when you need to replace an IED that has broken, and it's not a one-to-one replacement, to configure a new IED to fit in the scheme, simulate it in the scheme that you have fit before you put it in the live system. So there's a couple of possibilities in that area.
One of the hottest questions, and it is, what do you consider to be a digital substation, a truly digital substation? Any universal interpretation for that?
It's probably a similar question like when you ask what is a smart grid. If you ask 10 engineers, you probably get 11 answers. So it really depends. I mean, some consider a digital substation as soon as there is some communication, some numerical relay in. Others consider a digital substation that is fully equipped with a process bus and a sampled value, GOOSE transmission, breaker interface device. I don't think there is a unique answer for that. I mean, the more and more when we talk about digital substation, I think a lot of people have really in mind a substation that goes with communication down up to the process itself, to the primary equipment.
And can you name the most advanced utility in the world in terms of implementation of digital substations?
Not having seen them, but I mean, we hear a lot that China has plenty of substations using sampled values and process bus, basically. Most other utilities, to the knowledge I have, are having first field experience, sometimes prototypes. Mm-hmm. Some of them have built the first fully digital substation, like as an example, EDF, or no, RTE, I think it's RTE, not EDF. RTE has a fully digital substation where they went quite far as well. I mean, talking about digital substation and how far you go in the process, even there you can have variants. I know from some vendors that really have completely digitized the gas-insulated switchgear, including not just the breaker and switch interfaces, but also gas density measurement, all the equipment related to that integrated as well, mm-hmm. through own devices. And I think RT has one of those substations now finished. But as I say, mainly it's in the stage that utilities start to looking into it.
Okay, so the next question was, maybe there's a project that you tackled in your experience which impressed you a lot.
There's a couple of interesting projects. I have not been involved in all of them. An interesting project as well that I recently was involved was less from the fact that it was a digital substation. It was more from the perspective of a refurbishment project, which was with Consolidated Edison in New York. They are refurbishing a substation that consists about 8 high voltage feeders and then a ring bus with a dozen of sections and plenty of low voltage, I mean 160 kilovolt lines going away. So quite a large substation that they are now migrating to IEC 61850 under extreme conditions, like they only can take outages in the spring or in the fall, and only limited one because the substation is one of the core substations in Manhattan. So it's quite a interesting project from that perspective. It's not using process bus, it's a conventional approach towards the sensors because it uses the existing equipment.
Okay, but is it using GOOSE communications or?
It's using GOOSE communication for implementing the protection scheme. So basically everything that goes from one bay or from one section to another is using GOOSE. Fully redundant device and communication network, I mean independent communication network, main 1 protection, main 1 breaker interfaces, and main 2 protection, main 2 breaker interfaces.
Is there any chance that IEC 61850 will be replaced by any other standard, like it happened with Modbus, 6870 series, and etc., etc.? And what is done not to allow this and to preserve the leadership here?
Well, I think having a replacement standard it always requires some drivers behind. And at least once we focus on the substation automation business, I think all the major vendors invested a lot into that. I would not expect it happens there, that we have very soon a replacement. We have built in as well from the very beginning the concepts that we are a little bit independent from the communication technology. We have this separation from the model world and the communication world, which allows us to follow up with new communication technology if needed, not losing all the rest of the value. So, but in general, I think for the moment, I don't see any technology that will be there that would completely replace 6150 when it comes about substation. Application in other domains, and particularly when we look into distributed energy resources, so beyond the smart grid, this is still a little bit taking up only. There is also a lot of competing activities going on, all the kind of different initiatives. I think there it really depends a lot, but I think a lot of utilities see now the value that they have one unique approach across their different domains, which 6150 provides. So I think that's also helping a little bit to guarantee the future there.
Regarding communication technology, why MMS and Ethernet were chosen as a state-of-the-art or as a current that are used by the standard?
Well, that's an interesting question. I mean, when we started 61850, it was mainly a European-driven initiative. I mentioned there was a GOOSE coming from UCA, from the US, but initially they were more or less independent. So the start of 61850 was mainly driven from European countries, European users, but also European vendors. And at that time, every of these vendors had their own protocol that were using in substations, like LON from ABB or MVB, Profi Bus from Siemens, FIP from, at that time I think it was Arriva or Alstom. They changed names a couple of times. So that were the protocols that were initially there under discussion. And of course, every vendor tried initially to have his protocol, the one that would be used. But at a certain moment we also realized that would probably not happen. And that was also the time when we started to discuss with the US approach, which was EPRI at that time, to merge those together. And in the US, for the UCA, they had from the very beginning, they were building up on MMS, because MMS was already used for the TASE2 protocol, which was the control center communication, as part of an IEC standard as well. And they basically had their suggestion using MMS over Ethernet, and that was taken mainly as a compromise initially to address the not needing to use something from one vendor over another vendor. So that was part of the topic, part of the reason why it was chosen.
Okay, thank you. Another question. UCA is responsible for accreditation of test laboratories all over the world, so to perform 6150 conformance tests. Could you explain who entitled UCA for this job to provide these accreditations? And is it possible that there could come up another organization will take this job, overtake it?
Okay, UCA, as the name says, was, as I just mentioned before, was originated in this EPRI activities original. They had a users group based on that, and basically that users group became the users group for the 61850 plus some other standards. It was mainly the community then that was agreeing that within the concept of UCA we developed a test program and an accreditation program for test houses to do the testing. It was mainly an agreement from the community that was represented. From an IEC perspective, IEC does not select or prescribe anybody doing accreditation. It's even more, we cannot require one particular program as the only one. So in principle it's completely open. At the end of the day, it depends of course what the user community accepts and what the user community is willing to support.
Okay, it's clear. There are quite a few people involved in IEC 6150. And Working Group 10 is by far its largest group in TC57, I guess.
It's the largest group in IEC.
It's the largest group in IEC.
As of today, 265 members.
Okay, yeah. So how do you think, what makes companies and certain people spend their time and money on standardization? What is the main driver for them?
I mean, the main driver from a company perspective is, of course, that in order to stay up front of the technology, you better contribute to the development of the technology, and that's what you can do through standardization. User community, and that's good that we have again a little bit more users present than we had at a certain while. They have their interests and in influencing the standard to fulfill the needs they had. I mean, I mentioned the situation with the engineering interoperability. During a certain time, we didn't really have users contributing to the standard. Vendors have different interests in producing a standard than the users. So the easy interoperability for engineering was not necessarily the focus of the vendors, but it's definitely a key important point for users that want to do their own designs. So the users at a certain moment understood that they need to get involved as well as stakeholders to get the standard perform the functionality and the requirements they want.
The final question for you, Christoph. How much time do you spend on IEC 6150 in your life?
I better don't want to count that. Too much. From a business perspective, too much. No, I would say it's hard to really totalize it, but it's certainly about 20%, if not more, of a work time.
Okay, so do you feel the return of your time investments here? I mean, do you feel any feedback?
Yeah, to a certain level, yes. I mean, having my own consulting company, it certainly helps a little bit to stay in contact. It's mainly my marketing activities. I don't do a lot of other marketing. It's an interesting and challenging job, in particular to lead the working group and see the results over the years, the progress we made. So that's also part of the fun.
Okay, thank you and good luck. Good luck, Christoph.
Thank you.